Suppose we have the summation of 3 divided by n times n plus 1 plus 1 over 2 to the n starts from 1 goes to infinity. I'm going to break down this series into the summation of two series. This can be written as the summation of 3 divided by n times n plus 1 and start from 1 goes to infinity plus the summation of 1 over 2 to the n and start from 1 goes to infinity. So the very first sum can be written as 3 times the summation of 1 over n times n plus 1, and the second series is the summation of 1 divided by 2 to power n and starts from 1 goes to infinity. Let us go back to the definition of series and analyze each one of them separately. So I'm going to move a little bit down here. The definition of geometric series can be applied for the second series on the right-hand side. We have something that we call telescopic series. And to apply this method of telescopic series, I'll show you what to do. So for a telescopic series, we have the following case. Let me write it down here, then we can write down the final answer here. If you have a series of the form of summation of 1 divided by n times n plus 1, you can break this down using partial fractions. So by the method of partial fractions, we can write 1 divided by n times n plus 1 as 1 over n minus 1 over n plus 1. Then if you take the sum of both sides, the summation of 1 divided by n times n plus 1 and start from 1 to infinity must be equal to the summation of these two fractions. But if I plug in values, I get 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 plus the rest of the terms. You can continue this process and you end up with 1 over n. Let me just write down 1 over n for the sake of space. 1 over n minus 1 over n plus 1. So if you start analyzing this, you see that you have negative a half and a half, they get canceled out. A third and negative a third, a fourth and negative a fourth, a fifth and negative a fifth. The term before 1 over n is negative 1 over n. You can cancel these two out. So you're left with two terms in this series, 1 and negative 1 over n plus 1. So this series can be written as just two terms, 1 minus 1 over n plus 1. So your first series is nothing but 3 times 1 minus 1 over n plus 1. And if you take the limit of the quantity 1 over n plus 1 as n goes to infinity is equal to 0. So basically, you have 3 times 1 as the summation of the series here. You have 3 times 1. And again, this 1 is coming from taking the limit of 1 minus 1 over n plus 1 as n goes to infinity, which is 1 minus 0 or 1. That's how you get this one. For the second series here, let me use a different color. You have 1 over 2 to power n. What is this guy? So if I write down some of the terms of this series, what I have a geometric series. The general approach for geometric series is if you have a plus ar squared plus the rest of the terms, or the summation of ar to power n minus 1 and start from 1 goes to infinity, as long as the absolute value of r is less than 1, you have a convergent series which converges to a divided by 1 minus r. Okay, if you list some of the terms of this series, what do you see? You have a half plus a half squared plus a half to the third plus the rest of the terms. All right. So as you can see, the very first term is a half and r is equal to a half as well. A is a half, r is a half. So you have a convergent sequence as well. You get 1 divided by 2 divided by 1 minus a half. So if you combine these together, you can add these all. So let's see. Let me minimize this a little bit so I can move this here. So add these two for you. This is equal to 3 plus, so if you take common denominator, you have a half on the denominator. So what do you get? You get 3 plus 1 or 4. This sum converges to 4.